Hello and welcome to this IoT on AWS webinar session. My name is Ryan Little. I'm an AWS Educate Technical Program Manager here in EMEA. And what we're going to be talking about today really is all things IoT as they relate to AWS, and kind of specific subset of that, which is the IoT core. And really, the intended audience for this type of webinar is anyone that's interested or curious about the Internet of Things in general as a very much a growing concept and category within, particularly in cloud computing these days. And if you have a mobile phone or some kind of smart home device, Alexa or a light switch, it's probably leveraging some version of IoT on the back end. And so hopefully getting folks a little bit more familiar with that process. So this particular webinar could be for students, educators, developers, operations leads, technical leaders, and business analysts, potentially with some experience and or knowledge of IoT workloads and AWS IoT services. It's also applicable to customers in both the public and private sector. So we'll talk about introduction to IoT services on AWS. A little bit later, we'll look at actually walking through maybe a demonstration of how to create and receive and process what we call MQTT protocol or message queuing telemetry transport. So messages from the device using something called AWS IoT Core. And we'll go through a walkthrough of that. We'll also talk about really what types of customers are doing with IoT. What are the fundamentals of particularly of Internet of Things these days? We'll highlight just a section of what we call the IoT virtual wheel or virtuous cycle, and we're going to focus on connectivity and control services. So the main focus today is going to be on a service called AWS IoT Core, and then I'll give reference to AWS IoT Device Management and AWS IoT Device Defender. But as I said, we'll do a walkthrough of IoT Core a little bit later and talk about some of the specifics of that. And then towards the end of this webinar, we'll also look at some follow-up resources, including the benefits of AWS Educate. As I said, working for the AWS Educate team here in EMEA, much of the content that we put out is mainly for educators in delivering these types of sessions potentially to their students, or at least getting their students familiar with this process and leveraging things like our AWS Educate Classrooms environment, where you can actually stand up defined borders of AWS resource. These are free services available to educators and students. So, talking about a lot of the best practices therein. So, definitely stay connected. If you're not already a member of AWS Educate as a student or educator, make sure you sign up and become a member so you can take advantage of some of the benefits of that. And highlighting here just a public page. If you do a search for AWS IoT, you'll come to a page much like this, where it talks about, or really just gives a general overview of the IoT services on top of AWS. There's many that are listed there, and we're going to talk about just a small fraction of those today. Also, if you're curious about different IoT solutions that are kind of out there and available on the wild, a number of partners that specialize and focus on IoT services, and as well as some of our customers. So a great public resource available to all of you. I think there's some tutorials kind of embedded in there as well, so you can have a go at it and launching an IoT device or something like that through one of the tutorials. At AWS, we start our customer engagements, all of our customer engagements, for any type of solution with the customer working backwards. But for IoT, it starts with a simple question. And the question is, if you knew the state of everything and you could reason on top of that data, what problems would you solve? So our mission really is to make sure that you can know the state of everything at any given time on all of your devices, and that you can reason on top of that and get analysis or some enrichment of data or insight of that data, so you can really start to truly solve some of your unique business problems. At AWS, we have millions of customers in over 190 countries around the world. Many of those customers leveraging IoT solutions in their environments. Companies like Vizio, who selected AWS IoT Core for their complete line of smart TVs and sound bars, including a new line of TVs due for launch over the holidays. Pentair, which provides beer and water filtration systems to large industrial brewing customers. They're leveraging something called AWS IoT Greengrass, which means that they can ingest operational data to the cloud over time for machine learning and big data analytics, and deploy output of those analyses down to their local devices for local execution. NL, which is a very popular energy company, uses AWS for its platform for IoT and energy management. Again, this company is leveraging AWS IoT Greengrass via Greengrass enabled smart gateways for the home and industrial gateways for their power generation sites. And that's being used so that AWS IoT Greengrass will allow them to process and act on large volumes of data. Many others here, GE, for the work that they do for some of their Edge OS solutions for industrial IoT. Philips Healthcare is using it for their Health Suite digital platform, and they're taking advantage of a number of AWS services to manage, update, and remotely monitor and collect data for smart devices. And then we see with companies like Panasonic, Avionics, and many others. So a whole host of customers kind of leveraging these services for IoT these days in the places that they're in. So, if we look at the landscape today, for particularly for Internet of Things, we know that there are billions of devices in homes and factories and oil wells, hospitals, cars, and thousands of other places. And with the proliferation of devices, you increasingly need solutions to connect them and collect, store, and analyze device data. And the number of devices connected to the internet, including many machines and sensors and cameras that really make up this term IoT or Internet of Things, continues to grow at a steady pace. A new forecast from the IDC estimates that there will be over 41 billion connected IoT devices, or what we call things, generating almost 80 zettabytes of data by 2025. And for those up on our zettabyte knowledge, 1 zettabyte is approximately equal to about 1,000 exabytes, or a billion terabytes, or another way to put that is a trillion gig of data. So globally, we'll be up to that point, close to 80 zettabytes by 2025. But here you see companies like Fender who are using AWS services, including IoT Greengrass, to digitally transform their business. Greengrass allows Fender to provide quality assurance in the wood matching process when manufacturing guitars. So that's an example of them kind of optimizing manufacturing capability. We talked about Philips and what they're doing for remotely monitoring patient health care. We see it for connected homes like Vizio, iDevices, and Itron, for connecting homes and buildings and cities, and companies like Bayer, who are delivering crop data for analysis in minutes instead of days. And that's a huge help to many of the farmers. Helps them get better visibility into things like field conditions. We're also leveraging seeing many customers use a robust edge processing and analytics frameworks for a variety of different use cases as well. Another big advantage to IoT in the cloud is this idea of scale. So you can support not just one device, but potentially thousands, maybe even millions of devices for things like manufacturing, or other initiatives that you're looking to launch as well. So we said it was all about finding a solution to some level of business outcome, and that's really what it is. And so if you identify what the business problem is, it can map to a particular solution. IoT just happens to be one potential mapping. There could be others depending on the use case, but we're going to look through the IoT lens mainly for today. So this is what IoT strategies do for our customers. They empower our customers with the intelligence needed to build new services and business models. Also helps to improve products and services over time. Enjoy better relationships with their customers because they're able to understand their needs. Their business operations become more efficient, and actually they start to make more intelligent decisions faster and over time. And they all develop a kind of a data-driven discipline. And all of these advantages lead to effectively revenue growth and greater operational efficiency. And we see that translated over time with many of our customers as they start to use these IoT services more and more. So the question ultimately becomes, what are the fundamentals of AWS IoT? And there's kind of three key areas that we're going to talk about a little bit later. In the next slide, you're going to see the IoT virtuous cycle. But under the AWS IoT architecture, you see kind of three areas of focus. You see device software, connected and control services, and analytics services. And it's really when you start to leverage all three of these, particularly for IoT use cases, do you start to get the greatest amount of insights. For device software, it's asking the question, how can I build devices that operate out on the edge? So if I'm operating, let's say, a fleet of vehicles and I want to get the latest telemetry to and from those vehicles, how can I do that? Through what devices? For connectivity and control services, it's asking the question, how can I start to control and manage and secure my devices at scale? How do we mitigate against things like virtual attack on these devices, or someone wants to kind of use brute force and gain access or entry? How do we mitigate against that? How do we manage messaging from one device or several devices over time? How do we manage firmware updates, those types of things? And then there's the analytics services piece of the architecture. So asking the question, how can I make sense of my IoT data and take appropriate action? If I want to find out if all my devices are being used in the safest way possible with the latest updates and there's high customer satisfaction, how can I start to get some level of insight from our devices and using those? And what you see here is this introduces the IoT virtuous cycle. So the Internet of Things cannot exist without things, right? Without devices, effectively. Every IoT solution must first establish connectivity in order to begin interacting with devices. And AWS IoT is an AWS managed service that addresses the challenges of connecting, managing, and operating large fleets of devices for an application. Combination of scalability and connectivity and security mechanisms for things like data transmission within AWS IoT provides a foundation for IoT communication at scale and as part of an IoT solution. Once the data has been sent to AWS IoT, a solution is able to leverage an ecosystem of other AWS services spanning databases, mobile services, big data, analytics, machine learning, and more. And you see some examples of this IoT virtuous cycle. Now, we're not going to talk about all of these services today. We're mainly going to be focused there on the lower left under connectivity and control services. And at this level or at this layer, it's really the communication layer, which handles the connectivity, the message routing among remote devices, and routing between devices and the cloud. The communication layer lets you establish how IoT messages are sent and received by devices, and how devices represent and store their physical state in the cloud. AWS IoT Core helps you build IoT applications by providing a managed message broker that supports the use of the MQTT protocol to publish and subscribe IoT messages between devices. There's AWS IoT Device Management, which eases the organizing, the monitoring, and managing of IoT devices at scale when you want to launch a whole fleet. And we see it when we talk about at scale, customers are actually managing fleets of devices across multiple physical locations. And then there's AWS IoT Device Defender, which we'll talk about, which is a fully managed service that audits your device fleets, detects things like abnormal device behavior, alerts you to security issues, and helps you investigate and mitigate commonly encountered IoT security issues. So as we saw earlier, we talked about the IoT virtuous cycle. Now the question becomes, particularly under this category of connected and control services, how can I connect my data securely and handle the data they generate at scale? And one of the services that really starts to address this is a service called AWS IoT Core. Our cloud based service, AWS IoT Core, really forms the backbone for IoT deployments to securely connect all your devices and handle their data at scale. AWS IoT Core allows you to securely connect devices to the AWS cloud and also with each other. It allows you to do things like route process and act on the data and messages coming from those devices. And we're going to see examples of this as we move forward. It also enables you to really integrate with other services. When we talked about database or other analytics, machine learning that can be leveraged for further insights and clarity. The components of AWS IoT include the identity service, which is providing authentication and authorization, a device gateway to securely connect devices to the AWS cloud and other devices at scale. There's a message broker, which processes and routes data messages to the cloud. There's a rules engine. So, if you have AWS IoT service, which includes the rule engine that can trigger actions on your device. So that means it is capable of doing things like filtering or transforming and even forwarding device messages as they are received by the device gateway. The rules engine actually utilizes a SQL-based syntax that selects data from message payloads and triggers actions based on the characteristics of the IoT data. There's the device shadow that enables applications to interact with devices even when they're offline by maintaining what we call a virtual representation or shadow of the device. And then there's the registry that enables automatic device registration. So, in other words, it's a central location for storing and querying a predefined set of attributes related to each thing. And the device registry supports the creation of a holistic management view of the IoT solution to control the associations between the things, the shadows, the permissions, and the identities. And we said earlier that AWS IoT Core supports MQTT, the message queuing telemetry transport, which is a widely adopted lightweight messaging protocol designed for constrained devices. And MQTT participants receive information organized through MQTT topics. An MQTT topic acts as a matching mechanism between publishers and subscribers. And conceptually, an MQTT topic behaves like an ephemeral notification channel. And we'll see an example of this later when we do our walkthrough. There's also a library for building mobile IoT applications and supports both iOS and Android. So you can get supported programming for things like your Arduino, an SDK, AWS IoT device SDK for embedded C, or AWS IoT for C++ for device SDK, There's one for Java, JavaScript, and Python. So you can build your own connectivity and IoT capabilities. So you have that flexibility in your code. And then finally, there's cloud security at AWS, which is really the highest priority. And as an AWS customer, you benefit from a data center and a network architecture that is built to meet the requirements of the most security sensitive organizations. And so each connected device or client must have a credential to interact with AWS IoT. And all traffic to and from AWS IoT is sent securely over TLS, Transport Layer Security, and AWS Cloud Security mechanisms protect data as it moves between AWS IoT and other AWS services. So if we just highlight each of these kind of categories, we start first with the identity service. Here you can bring your own your root, what we call your root CA and client certificates, or let the AWS IoT Core generate your root CA certificates for your devices to verify that they're communicating with AWS IoT Core and not some other server impersonating AWS IoT Core. Um, there's also the ability for it to automatically provision large fleets of devices with unique identities on their first connection using something called fleet provisioning. There's also support for things like SIG v4 and X509 and custom authentication if you want to leverage things like AWS Lambda to help negotiate added support for identity. A device gateway, we said, is responsible for maintaining the sessions and subscriptions for all connected devices in an IoT solution at scale. It really securely connects devices to the AWS cloud. And it's doing things like enabling secure, long lived connections for what we call bidirectional communication over MQTT and WebSockets and HTTP. Secure communications over TLS 1.2 for mutual authentication. And then there's a per device X509 certificate enableability and fine grained policies per device and per user. You can also get into things like automatic device provisioning with just in time registration. And so, it's actually in reference to things like the Atmel microchip, the ECC 508, which is custom fitted. It's an AWS ready crypto chip that generates unique keys chained to pre registered signer certificates of a customer's AWS account. There's the message broker, which routes data from these devices. And we said this was a two-way message streaming between devices and applications. The benefit of this is that it's scalable. There's low latency and reliable message routing that goes along with it. It uses a pub sub mechanism, so publish and subscribe for decoupled devices and applications, and acts as a publish and subscribe protocol. And MQTT inherently encourages that scalability, the scalable fault tolerant communication patterns, and fosters a wide range of communication options among devices and the device gateway. And then we also can talk about support for quality of service. And so, in addition to the MQTT protocol, it exposes different levels of quality of service to control the retransmission and delivery of messages as they are published to subscribers. The combination of publish and subscribe with QoS not only opens up the possibilities for IoT solutions to control how devices interact in a solution, but also drive more predictability in how messages are delivered, how they're acknowledged, and maybe even how they're retried in the event of network or device failures. There's the rules engine. So the rules give your devices the ability to interact with AWS services. Rules are analyzed and actions are performed based on the MQTT topic stream. And the rules engine is capable of, we said, filtering and transforming and forwarding device messages as they are received by the device gateway. It also can work. Actually, AWS IoT also provides Device shadow, and maintains a virtual representation of the device we mentioned. But you can use rules to really support tasks like think about augmenting or filtering data received from a device. Maybe you want to write data received from a device to an Amazon database like DynamoDB, or maybe save a file to S3, or maybe even push notification to all of your users using something like our notification service, Amazon SNS. So those are just a few of the examples on how you can start to define the rules for your IoT devices. We talked about device shadow earlier. Basically, what device shadow is a JSON document that is used to store and retrieve current state information for a device. The device shadow service maintains a shadow for each device you connect to AWS IoT. So you can use the shadow to get and set the state of a device over MQTT or HTTP, regardless of whether the device is connected to the internet or not. Each device's shadow or virtual kind of presence is uniquely identified by the name of the corresponding thing. And the device shadow, device SDK, and APIs enable applications to interact with devices even when they're offline. So that could be for cloud representation of device state, or maybe querying your last known state for offline devices or real time state changes, maybe tracking the last known device state, or controlling devices via change of state. You see actually many examples of that, or even automatic synchronization once devices connect to the cloud. And then for managing the lifecycle of a fleet of devices, AWS IoT has a device registry. The device registry is the central location for storing and querying a predefined set of attributes related to each thing. The device registry supports the creation of a kind of holistic management view for your IoT solution to control the associations, as we mentioned, between things and shadows, permissions, and identities. And we have a customer here, iRobot. The problem that iRobot faced was that it had previously only operated primarily as a kind of a hardware vendor, and it was about to bet most of its central line of business on its ability to run a high availability, customer facing cloud application and an Internet of Things backend platform. So it was a huge digital transformation that they underwent as a business, including with the product that they had as well. And what they found was iRobot uses AWS IoT and other AWS products to power its Roomba vacuum cleaners. And so, if you've ever come across any one of those automatic cleaners on the ground, and if it's an iRobot product, more likely than not, it's leveraging IoT on the back end. And what they did with these Roomba vacuum cleaners, they mapped more than 500 million square feet of floor space as part of the company's smart home vision. And iRobot was able to manage the solution with actually fewer than 10 people in their business. AWS IoT Core, which can process trillions of messages between billions of devices and AWS or other endpoints, helped iRobot provide the connectivity layer between the robots and the iRobot cloud platform. If you have ideas to bring Alexa voice service to the IoT. So here we're just going to do a quick IoT Core walkthrough, and I'm just going to show you, I have a couple of slides just to highlight kind of a walkthrough of how to create resources required to send and receive and process what we call the MQTT messages from devices using AWS IoT Core. And you use an MQTT client here to emulate effectively an IoT device. But if you have a Raspberry Pi or some other physical device, you could leverage this service as well. So I said that this session really was geared toward educators and students who are leveraging our AWS Educate portal. So the very first thing I would recommend educators to do is to, if you haven't already signed in through the AWS Educate portal, to go ahead and do so. From there, the recommendation is to create a classroom, and we have documentation in Educate to walk you through that. You'll want to create a classroom, which is a predefined AWS console experience for you and your students. From the classroom creation, you can access the AWS console. And then once you open up the AWS console, you look for AWS IoT. And then on the welcome page here, you choose to, you click on Get Started. The next thing you're going to do is create a thing, right? And we said that the thing is effectively going to be representative of the device. Devices connected to AWS IoT are represented by what we call things in the AWS IoT registry. And a thing represents a specific device or logical entity. It can be a physical device or a sensor, for example, a light bulb, or switch on the wall. It can also be a logical entity, like an instance of an application, or a physical entity that does not connect to AWS IoT, but is related to other devices that do. So, for example, a car that has maybe engine sensors or a control panel. And to create a thing, once you go to the AWS IoT console page, you look at the navigation panel on the left, and you choose Manage. And then you have an option to, well, it actually highlights that you don't have any things yet on this page, so you can choose to learn more or to register a thing. We're going to click on registering a thing. And then once we do that, or we choose to create a thing, on the create a thing page, it's going to ask you to name that item. So it could be like name that thing. So your my IoT thing. And then you'll be able to carry on to the next step, which I'll show you. The registry allows you to keep a record of all the devices that are registered to your AWS IoT core account. And the process of registering your device includes steps like creating and activating a device certificate, creating an AWS IoT core policy, attaching an AWS IoT core policy to a device certificate, and attaching a certificate to a thing. Communication between your device and the IoT core is protected through the use of X509 certificates. AWS IoT Core can generate a certificate for you, or you can use your own X509 certificate. In this tutorial and in walkthrough, AWS IoT Core generates the X509 certificate for you. And important to know that certificates must be activated prior to use. And here we see on the certificate created page, choosing the options to download the certificate, the private key, and the root CA for AWS IoT Core. And you can save each of them to your computer and then choose Activate to continue. So we said X509 certificates are used to authenticate your device with AWS IoT Core. And AWS IoT Core policies are used to authorize your device to perform different operations within IoT Core, such as subscribing or publishing to MQTT topics. Your device presents its certificate when sending messages to AWS IoT Core. And to allow your device to perform those operations in IoT Core, you must create an AWS IoT Core policy and attach it to your device certificate. As you can see here, to create an IoT Core policy, you navigate to the navigation panel, choosing Secure, and then choose Policies. And then on the You Don't Have a Policy Yet page, you can choose to create a policy. On the Create a Policy page, as you see here, you can give a name for that policy, and make sure it's identifiable. So you could use something like My IoT Policy. And then, of course, you can define an action and something like IoT Connect. It will give you it will ask you for the resource ARN, and you want to also select the appropriate setting for that. Here is a kind of wild card, so selecting all. And then click the allow checkbox, and this allows all clients to connect to the AWS IoT Core. Of course, you can restrict which clients or which devices can connect by specifying the client ARN as the resource. And so they follow a very specific kind of format that's in our documentation as well. And then once you're done, you hit create. Now that you've created a policy, you must attach it to your device certificate. Attaching an AWS IoT Core policy to a certificate, it gives the device the permissions specified in the policy. And then you see here as you navigate to this page, in the box for the certificate you created, you choose here to open a drop-down menu and then choose Attach Policy. In the Attach Policies to Certificate, you're going to select the checkbox next to the policy you created in the previous step and then choose Attach. A device must have a certificate, a private key, and a root CA certificate to authenticate with AWS IoT Core. So we recommend that you also attach the device certificate to the IoT thing that corresponds, that represents your device in the AWS IoT Core. So this allows you to create those core policies that grant permissions based on certificates attached to your things. And then to communicate with AWS IoT Core, all devices must have a device certificate, a private key, and root CA certificate installed. And you can look at maybe your device's documentation to connect to it and copy your device certificate, private key, and root certificate onto your device. If you don't have an IoT ready device, you can use the MQTT client, the AWS IoT device SDKs, or the AWS CLI. So here, you can use the AWS IoT MQTT client to better understand the MQTT messages sent by a device. So devices typically will publish MQTT messages on different topics, and you can use the AWS IoT MQTT client to subscribe to these topics and to see these messages here. And then also important to note for this particular slide, if you want to view those messages, you can navigate to the IoT page, and on the navigation pane, choose Test to be able to test some of those messages. And here we've navigated to the MQTT client and looking to test that publisher and subscriber message protocol. So here you subscribe to the topic on which your IoT thing publishes. You continue with this example here and subscribe to a topic. In the subscription field, you can enter a topic of your choice and then choose subscribe to topic. For this step, looking to emulate an IoT thing sending a message. On the MQTT client page, in the publish section, in the specify a topic and a message to publish field, we can enter the topic, which is my/topic. And then from here, we see a little bit of JSON here. And that's some JSON will be denoted in the message payload section. Here, the message is hello world, the client type of MQTT client. And then at this point, we choose to publish to topic. And you should see the message in the AWS IoT MQTT client populate here. We could also use the Amazon SNS, Simple Notification Service console, to create an Amazon SNS topic. You'd enter a topic name and display name, and then choose Create Topic. And we can get updates also via our mobile phone as well, so you can get updates on the specific device. AWS IoT Rules Engine listens for incoming MQTT messages that match a rule. And when a matching message is received, the rule takes some action with the data in the MQTT message. So, for example, if you're looking to write data to an S3 bucket, or invoking a Lambda function, or sending a message to SNS, that rule will be enacted. So in this step, you'd create and configure a rule to send the data received from a device to an Amazon SNS topic. As far as creating a rule, AWS IoT core rules consist of a topic filter, rule action, and in most cases, something called an IAM role. And of course, we have documentation in our AWS IoT core tutorial that you can follow for this. But messages published on topics that match the topic filter trigger the rule, and the rule action defines which action to take when the rule is triggered. The IAM role contains one or more IAM policies that determine which AWS services the rule can access, and you can create multiple rules that listen on a single topic. Likewise, you can create a single rule that is triggered by multiple topics. And the AWS IoT core rules engine continuously processes messages published on topics that match the topic filters defined in the rules. So in this example here, you can create a rule that uses Amazon SNS to send an SMS notification to a cell phone number. And so here in the AWS IoT console, we can choose to create a rule. And if we scroll down to the rule query statement, you can choose the latest version of or the latest SQL version for your rule from a drop-down list. And then in the rule query statement, in this example, we enter a SQL query for select star from my topic. So select all from my topic. And the select all again specifies that you want to send the entire MQTT message that triggered the rule from my topic, which is the topic filter. And the rules engine uses the topic filter to determine which rules to trigger when an MQTT message is received. And you can also use AWS IoT Core jobs to deploy and track management tasks in your device fleet. So as your device fleet grows, and invariably it will if you're leveraging many devices, you can assign, you can use jobs to send remote actions to one or many devices at once to control the deployment of jobs to your devices and track the current and past status of job executions for each device. So this topic shows you how to create and deploy a sample job to a device. It walks you through the steps required to create a job and track its events on a device that is configured to communicate with AWS IoT Core. And what are some possible scenarios where you might be using jobs? Well, it could be to maybe updating device firmware or software or files such as security certificates, maybe performing administrative tasks such as restarting devices or performing diagnostics, maybe restoring devices to factory settings or other known kind of good states. And here's just an example that you'll see once the job is done, or when the job is executed on your device succeeds, AWS IoT Core publishes a job execution succeeded event. And you can see this event in the console by navigating to the test page and subscribing to that particular topic in the MQTT client. So we talked quite a bit about AWS IoT Core and creating a device and creating certificates associated or leveraging your own certificates and kind of managing different aspects of that in regards to the MQTT protocol and also if you're leveraging notifications via SNS. But here the question is, how can I manage my growing fleet of connected devices at scale? So we talked about kind of those three key factors that are associated with connectivity and control services. And AWS IoT Core was the first one. And I'm just going to give reference to the other two just at a very high level so you're just familiar with them and know what they are and what they do. The second critical service associated to connectivity and control services is AWS IoT device management. And as many IoT deployments consist of hundreds of thousands to millions of devices, it is essential to track and monitor and manage connected device fleets. You need to ensure your IoT devices work properly and securely after they've been deployed. You also need to secure access to your devices, monitor their health, detect and remotely troubleshoot problems, manage software and firmware updates, and AWS IoT device management makes it easy to securely register, organize, monitor, and remotely manage IoT devices at scale. And with AWS IoT device management, you can register your connected devices individually or in bulk and easily manage permissions so that devices remain secure. You can also organize your devices, monitor and troubleshoot device functionality, query the state of any IoT device in your fleet, and even send firmware updates over the air or OTA. And AWS IoT device management is agnostic to device type and OS. So you can manage devices from constrained microcontrollers to connected cars, all with the same service. And AWS IoT device management allows you to scale your fleets and reduce the cost and effort of managing large and diverse IoT device deployments. And with AWS IoT device management, ultimately, then we also have to ask the question, how do I ensure my connected devices stay secure? So on this theme of security and secure tunneling, and many other layers of security and encryption, we are introduced to a service called AWS IoT Device Defender. In August 2018, we launched AWS IoT Device Defender service that helps customers have IoT resources associated with their devices. It also monitors your device fleet for abnormal behavior that might indicate a potential security issue. And it alerts you if something doesn't look right, like traffic from devices to an unauthorized IP address or spikes in outbound traffic that might indicate that a device is participating in a DDoS attack. And finally, through its integration with IoT device management, IoT Device Defender lets you take corrective actions to keep your devices secure. With AWS IoT Device Defender, it keeps your fleet secure. First, it continuously audits the IoT resources associated with your devices to make sure that they aren't deviating from security best practices and alerts you if something looks like it isn't compliant. So, for example, one best practice is not to share certificates across devices. So let's say during provisioning of additional devices, someone reuses a certificate. This will be flagged and you'll get an alert. An IoT Device Defender comes with 10 security best practices that you can select and run as part of the audit, and you can add your own as well. The second thing IoT Device Defender does is monitor your device fleet from abnormal behavior that might indicate a potential security issue. IoT Device Defender lets you define the expected device behavior for different sets of metrics. Then it monitors the device fleet and alerts you if something doesn't look right. So, for example, IoT Device Defender lets you define what ports should be open on the device, who the device can talk to, and how much data it sends or receives. Then it monitors the device traffic and alerts you if something doesn't quite look right. And then lastly, through its integration with IoT device management, IoT Device Defender lets you take corrective action like rebooting a device, updating its firmware, or revoking its permissions via a change in policy. So there you have it. The three components, if you will, of under connectivity and control services: AWS IoT Core, which we did a walkthrough of, AWS IoT Device Management, and AWS IoT Device Defender. We also built a broad partner ecosystem for AWS IoT. We work with partners along the entire value chain, from chipset manufacturers to device makers, OEM, operating system providers, and communication companies and operators, as well as ISVs and consulting companies. So here we're going to transition from kind of IoT services and features and kind of AWS IoT service capability into understanding a little bit more about AWS Educate for educators as well as students. So, if you are an educator at an institution and you are looking to integrate AWS learnings into your course, into your curriculum, we even have some higher level institutions creating what are called cloud degrees, so cloudifying their curriculum. If one were able to connect and join with AWS Educate, there's many benefits for educators who actually sign up as members of AWS Educate. The first is getting access to AWS Educate curated content. This is created from AWS subject matter experts, as well as what we call cloud ambassadors, educators around the world who have signed up to educate and are integrating into classrooms and actually producing unique content for their students and other educators. So you can contribute to our content repository in that space. As an educator, you can provision student access via AWS Educate Classrooms. We say classrooms here are predefined environments where each student is given a pre-allocated credit to run a number of services on top of AWS. This is at no cost to the educator or to the student. In fact, all of AWS Educate is free for educators and students. And classrooms, I often say, is one of the biggest secrets of Educate because you get additional credits to explore in that space. And of course, classrooms are helpful because it allows you to build on top of AWS for free and experiment with things like IoT or big data or machine learning capabilities. And if you're an educator who has been integrating with AWS Educate for some time, there's will be opportunities to become and join our Cloud Ambassador program, which is a yearly program. We look for kind of new educators in this space that want to contribute either to the content repository, maybe mentorship, or maybe co-facilitating or co-delivering webinars with AWS teams. So there's all sorts of opportunities that you get, and sometimes first access to new services, to new AWS Educate capabilities and features as they come out. And of course, that also ties into our professional learning opportunities for educators. And so, as and when trainings are available, too, you can take part in those. And there's a whole host of professional learning links within AWS Educate as well. And other benefits, depending globally where you are, for things like AWS in-person training discounts, discounts on potentially on certification exams, and no cost access to AWS e-learning courses. So, in addition to the badges and pathway content that is designed for students, and also as educators, you have access to that learning content as well, are the virtual classrooms. So, this again is a great tool to enable your students to really get their feet wet with AWS services in a safe environment. We provide our students with an AWS Educate starter account that allows them to use the console and services without the requirement of a credit card. And using credit, AWS credit, we provide so that there's no fees that are incurred through AWS Educate and also through these classroom environments. The benefit of AWS Educate Classrooms is that educators can also check the work that's done in those classroom environments. So you have the ability to kind of peer into a student's classroom environment to see if they've completed an assignment or to troubleshoot if they have any particular issues going on in the console. You can help them with that. Other capabilities that are listed here are so you can request a classroom, you can request credits for your class, so you can actually link your AWS full account to an Educate account, and you can request kind of bulk credits for your classes as and when you need to. There is some lead time for that, so make sure you give proper lead time. Usually it's several weeks in advance. And you can also tie in AWS Educate into your LMS. So if you're using things like Canvas, Moodle, or Blackboard, there's easy integrations to link up Educate in those LMS systems. Or you can request registration links for your class and have them sign up directly via a link. If the student is not an AWS Educate member, it will walk through that process to help them become a member and they can access your classroom. So I talked about the Cloud Ambassador program. This is it's an additional benefit, particularly for educators, and it provides them uh, a program where educators are chosen from among AWS Educate educator members via an application process, which typically opens in February every year. And the benefit of being a cloud ambassador is that it's a great way to connect to a community, a global community of educators who are passionate about AWS and cloud technology, and they want to help AWS Educate continue to become an ever more valuable resource to use and leverage. From the student's perspective, we'll talk about some of the benefits associated to AWS Educate. For many students, as they look to understand kind of what cloud is, and if, as an educator, if you're integrating these environments into your students' courses, we found actually and how AWS Educate was born because we saw a huge demand in the industry for the skills that are needed, in particularly for cloud. And I don't. It's no secret that most organizations today still struggle to find the very best talent in these fields. And so we saw the industry demand, and we saw an opportunity here that also where educators could integrate solutions into their classroom. And so AWS Educate was fundamentally born to help give students and educators the necessary skills in order to go for those cloud career jobs that are available. Specifically for students, we've outlined something called Cloud Career Pathways. We currently have 12 pathways that map to some of the most in-demand jobs in the industry. So, typically this could be things like software development engineer or cybersecurity specialist or data scientist or machine learning specialist. We've take those industry demands and skills that are needed and map those to kind of learning what we call career pathways. Effectively, what they are just modules of contained learning in a given field or a given career to help build cloud knowledge based on that competency. These are available to all students. Educators have access to these cloud career pathways as well. So for assigning to their courses, or if they want to have their own professional development, they can take part in the cloud career pathways. But each of these has anywhere between 25 and 50 hours of content. It's a mixture of labs, text, and video. And then upon completion of a pathway, they get a credential and they can share that credential with prospective employers to show what they've learned. And so that's where we help kind of bridge the gap between student and employer and help them get access to viable cloud jobs. So they learn cloud skills for careers in cloud computing at no cost. Each pathway is aligned to, as I said, to the in-demand job roles that are available to them. In addition to cloud career pathways, we also have something called badges. Again, this is available for students. Educators also have access to this for assigning to their courses or for their own professional development. They can unlock AWS Educate a badge in one of the industry's fastest growing interest areas, including building out things like Alexa skills, gaming, and even Internet of Things. Each badge features between 10 and 15 hours of self-paced content to expand cloud skill sets with a specialized focus on the coolest technology today. So here, if you remember in the earlier slide, we talked about cloud career pathways. So that could be an ongoing assignment maybe throughout the course, whereas badges might be smaller chunks of time, 10 to 15 hours. So this could be over a week or over 2 weeks. You could assign a given badge to your student courses for them to complete for, let's say, an IoT badge. And then we have the job board available for students. The AWS Educate job board hosts thousands of cloud jobs from some of the most in-demand employers around the globe, and students can find active cloud job postings and internships offered by Amazon or partner organizations. And it's really the best way for students to get a job or internship is to learn cloud concepts via the cloud career pathways or the badges, practice their skills on the AWS console via the classrooms, and then apply for a job or internship that matches their new skill set. Building a digital portfolio in AWS Educate is an important step for students to get in front of prospective employers, and it allows students to create what we call a digital profile of their academic, professional, and extracurricular experiences. And students can upload their resume, showcase earned digital pathway and badge credentials. They can upload projects and share personal social media channels with their employers. So if you're interested in this particular slide deck, I will share a link with you that where you can download a PDF of a deck that's very similar to this. This deck has been condensed for this webinar, but if you want the full deck, we actually have a link to share with you all. As well as other links for continued learning. We have about 9.5 hours of content as well on our training certification page, specifically for IoT. There's our AWS IoT developer guide as well that gives uh, kind of um, all the information that you would need to help get started for AWS IoT um, projects. I want to thank you again for your time. My name is Ryan Little, AWS Educate Technical Program Manager, and for sitting in on this IoT on AWS webinar session. We're just going to transition now and take a few minutes for questions towards the remainder of the webinar. All right, thank you everyone for attending this IoT on AWS session. Again, my name is Ryan Little, AWS Educate EMEA Technical Program Manager. Very happy, very excited to have all of you here today. And I just want to take a few minutes to answer a few questions that folks had along the way. And then I do have a very special guest that I'd like to introduce to you all as well. So just checking a few things here. Okay, bear with me. So a question earlier came up, in what ways are IoT devices connected? And so great question. We did a walkthrough of AWS IoT Core and finding ways in which you can connect. We also mentioned AWS IoT device management as a service under the connected services aspect of the virtuous cycle. So I would say look to AWS IoT Core and IoT device management for particularly if you have fleets of devices. But IoT device management makes it easy to securely register and organize, monitor, and remotely manage IoT devices at scale. And so that becomes important as you start to leverage things like multiple certificates, multiple permissions, and security along the way. Is chat enabled with IoT? Well, actually are starting to see integrations with something called the Alexa voice service, which enables you to access cloud-based Alexa capabilities with the support of AVS Alexa voice service APIs, hardware kits, software tools, and other documentation. So that really helps by simplifying building what we call voice forward devices with Alexa built in by handling complex speech recognition and natural language understanding in the cloud. So I would say, if you want to integrate chat into the IoT landscape, look to Alexa Voice Service to get you started. Or we have a number of partners in this space that specialize in IoT and potentially have some chat interconnectivity via chat there as well. And questions on AWS remote work and learning. We do have a page, and I'll try to pull it up here for you for the remote work. It's an ongoing page that we have for many educators and students, particularly in the times that we're living in. And so it helps with that aspect as far as various webinars like this, IoT. We recently did a RoboMaker session as well. And so I would encourage all of you to access that link, and I'm just going to drop it in the chat for you here just now, just so you have it, and that can help answer questions, particularly in the times that we're living in. So at this time, I'd like to introduce a very special colleague of mine, also a fellow Amazonian, and he is a he's in the solutions architecture team for the public sector at AWS, and he's not only worked with IoT, he also does a little bit of, or he's dabbled in with virtual reality as well, which is another kind of growing and emerging field as well. So what I'm going to do is just hand it over to my very dear colleague Ahmed El Hua, and he's going to talk to you briefly about his experience with IoT and a little bit on his background as well.
Thank you, Ryan. Can you hear me?
Yep, I hear you just fine.
All right. So let me take over the show my screen. All right. So let me just maximize this one.
And I can see your screen, so that's wonderful.
All right. Nope. Okay. Just bear with me a moment. Let me fix the. Okay. Is it better now? Full screen?
Full screen. Yep.
All right. Perfect. Okay. So thank you, Ryan, for the nice introduction. And hello, everyone. My name is Ahmed Al-Haw. I'm happy to be here today to show you a quick demo. I'm an AWS Solutions Architect. I'm based out of Bahrain, and I'm going to show you a quick demo on IoT integrations. So without further ado, this will take just less than 10 minutes, so please bear with us. What I'm going to show you now is a demo on how to see pollution in a visual way, and the demo is actually on YouTube. I've posted it earlier, so let's go there and see the video. So this is a recorded video of Amazon Sumerian, which is our VR service. And within that, you can easily integrate with IoT, and we'll talk about the solution. But first, let's look at what it does. So let's play that. So what you can see here is the sensor measurements on the left and on the right. I have two sensors, a sensor for pollution and a sensor for humidity and temperature. And I'm going to pause the video for a moment. And this is the hardware component of it, where you have a Raspberry Pi 3, and I have a DHC11 sensor connected to the Pi, and I have another sensor called Nova PM sensor for pollution and air particles. And with that, we have an SDK implemented and connected to IoT Core. And from IoT Core, we have it connected to Amazon Sumerian. Let's continue the video, and then we'll talk about the architecture. So here you can see that I'm gonna blow some dust next to the pollution sensor, and you can see on the right hand side the gauges are starting to change in real time. And then you will notice that the smoke here is also changing to become darker, and Preston as well, the VR host, is reacting to that. In a while, the air pollution settles and the particles measurements start to drop. As you can see here, they take time for the air to settle, as you can see, and Preston has changed his position on that one. And these are just the messages to IoT Core. And again, we try another, blowing some ash this time, and you will see completely through the roof measurements and different color now, and Preston has really been upset about that. So that's the demo very quickly. Definitely just wanted to show you that this is the recording of the actual Sumerian. So Sumerian is a service. You can see here, this is the actual web graphics of it. And this is the actual boat where I can zoom in and walk around. Now let's get back quickly to the couple of slides to talk about how is this done. All right, so the architecture very quickly, you can see here the Raspbian or the Raspberry Pi. You can have Raspbian OS, or you can try it with Ubuntu ARM version as well. I've tried both on separate Pis and it works perfectly fine. We implement the Boto 3 or the Python IoT SDK on the Pi, where we can start pushing MQTT messages to AWS IoT Core. From AWS IoT Core, really have two parts of it. For the VR and the AI part, with native integration to Amazon Sumerian, we can play the scenes and do your scenes. And you can integrate with Lex, which is our conversational AI service for chatbots. And you can also connect with Poly, which is our text-to-voice service. And now that's for the VR part. As for the analytics and dashboarding, if you want to do more with the data that you ingest into the platform, we have Kinesis to stream the data, and then you can store it in Redshift, which is our data warehouse, and visualize it with QuickSight, our BI tool. We're going to see that as well. And for if you prefer to use an ELK stack, you can also integrate natively with Elasticsearch from IoT Core and visualize in near real time with Kibana. Now, this is all deeply integrated. So when you use an AWS service, you get the benefit of deep integration. There is no programming required extra. There is no servers needed. This is all serverless. And here you can see a dashboard on QuickSight with the actual air pollution measurements over time. And you can see, for example, different dashboard visuals here, average humidity by timestamp and so on. And for the SDK, which Ryan has touched upon before as well, the landing page of GitHub, our official AWS GitHub repositories, you can find here. And these are the two SDKs that I typically use. So for the IoT SDK Python, this is the link. And if you want to do something with JavaScript as well and completely self-service, you can find here a lot of easy get started examples. I also work with JavaScript SDK quite often. And last but not least, my personal experience is that I've done this all in a self-service fashion, and so you can definitely use the console, or you can use the programmatical approach by APIs and CLI, and you are as fast as your sensor or thing is. This means I've really had great experience visualizing the sensor readings on Sumerian in almost real time. And the sensor response time is the one thing that can limit you. For example, the temperature sensor reads a maximum 30 seconds. Every 30 seconds, it gives you one reading. Otherwise, it will not give you the intended results, and so on and so forth. And thank you for having to listen to me for 10 minutes. I hope this was useful and was a good demo for you. Over to you, Ryan.
Thanks very much, Ahmed. I appreciate that the time you took for that. So very interesting. So that kind of answers the chat capability. When I saw Preston speaking and integrating with IoT sensors. So all sorts of services being integrated there, particularly for virtualized environments and virtual reality environments as well. So thank you for those exciting demos and backgrounds and getting started. There was quite a few questions actually on how does one get there, and so as to your level of experience, Ahmed, and maybe you can speak to this just briefly, but it really comes down to just testing and trying and experimenting and getting better as you go and iterating in that process. Look to our internships as well that we run throughout the year. And aligning yourself to organizations that are doing what you want to be doing. I don't know if there's anything else you'd like to add to that, Ahmed, but very,
No,
very, very good
I think
experience.
you pretty much summed it up. Yes, it's again, I would like to reiterate on the self-service part. Really, each one can really get very familiar with the AWS console and start building on AWS using serverless technologies, which take off all the heavy lifting of managing servers, something that maybe the younger generation today don't really care about or do much of. So yeah, start leveraging serverless on AWS, start building on AWS. Documentation is there, blog posts are there, videos are there. We are here to help. And yeah,
Wonderful. Thank you. Thank you for your time, Ahmed. I appreciate it. And just to let everybody know, I just posted into the chat window the link to the PDF of several of our IoT presentations that we have historically at AWS. I felt like the link that I shared is probably the most relevant to today's session. So have a look at that. Also, the AWS IoT Developer Guide, which does quite a bit and gives a walkthrough that we did of IoT Core. Ahmed is linking in that demo video as well there. So make sure you click on those links, bookmark them, and go back and review for later study. I'd like to thank everybody for our session today, for attending. Hopefully you found some value and some input into this. And please let us know if there's other services, other areas that you'd like us to focus on and give highlights to. And stay connected. My recommendation to all of you, if you're a student or educator specifically, go ahead and go to our AWS Educate page and register and get signed up, and then you can get access to AWS environments. The AWS Educate is a free service, so there's no reason why you shouldn't be able to do that and definitely take part. And we have students and educators all over the world taking advantage of that. So hopefully you can go and explore. Thank you again. My name is Ryan Little, Technical Program Manager for AWS Educate in EMEA, and hope to see you again at a future AWS session.